All right, guys, as I was saying now, remember now what we really want to find the height of men less than 157 centimeters. So we say on our x-axis would give you the height. What height that we are concerned with? 157. So we are saying that on a graph paper, you should be able to determine exactly on the x-axis where 157 would fall. I am estimating on this graph that it would be right here. Now, so on this graph, you have 157 centimeters the height. Now this 157 don't tell you the number of men who have
the 157 cannot be there. It should be between 154 and 159.5.
Thank you very much. Thanks much. I think I've totally overlooked where I'm putting it. So it would be right here, somewhere here.
So that is directly in the middle.
All right, so
it's 2.5 more than 54.5 and 2.5 less than 159.5.
all right, so let's say that it would be somewhere here then. All right. So as I said, this is just a rough estimate. If you have your graph paper, you'll be able to correctly find a location. So it would be 157 here from our estimation. All right. Now, as I was saying, the 157 here only tell you the height, but it doesn't tell you how many persons with the height of 157. Now, if we are to find how many persons that have the height of 157, what would we do? What would we do, students? Go ahead, Ms. Wilson.
Sir, would it be where the line meets the ogive?
All right.
From there and then we go across.
So what line would we construct to meet the ogive now? A horizontal line?
The line from 157 going up.
All right, so it means that we would have to construct a vertical line from that 157. So you would use a ruler and draw a dotted line from this point to meet the ogive. And then now, where it meets the ogive, we go across horizontally to meet our y-axis. Now, if the value that you read off here would be approximately how much?
Roughly 15, sir. Or
All
maybe.
right. All right, so let's say it's approximately 15 or even 16 if you may. All right, so just by estimation. Everybody agrees with that estimation? Now this would tell you that you have 15 men of height 157. But remember now, that's not what the question asks you for. They ask you how many men has height less than 157. So 15 men has height 157. So what we would have to think about now is that a height of 157 would be within this region, because if this is 157 here and you're going back in this direction, these heights would be less than 157. So if we shift a little less than 157, let's say 156, and go up and meet the ogive and come across, it would come somewhere about here, which is about, say, 14, right? So from this, we would have about 14 men with a height less than 157, whereas 15 men would have a height of 157. Is that clear to you guys? Anybody? So,
Yes, sir.
so just to repeat what I'm saying. Now, 157 would be somewhere there. You go up with your vertical line, meet your ogive. Then you go across, meet your y-axis. Now, if this, well, based on this arrow, this is showing that the height would be approximately, say, 14. So 14 men would be approximately 157, but we cannot say that 14 men has a height less than 157, because based on this, we know that exactly 14 men has a height of 157. But we know that all the values, all the men, the men less than 14. So 14 men would be 157. But if we go below 14, we would have 13 men. So all of these values coming right down on the x-axis would be values less than 157. So we can count from here to here to just little below the 15, which is 14. Sorry, just below the 14, which is 13. So we would conclude that 13 men would have a height less than 157. So that's what we are saying. So the height there would be 15 of 157. And we would conclude that it would have to be 14. Now, the other part of the question, if we could go back to it. The other part of the question asks, so the other part of the question asks, how many men have height between 155 and 165? Going back to ogive now, we'd have to go now back to the x-axis to find those two heights. So we want 155 to 165. Now it means then we would have to find two vertical lines, one where we have 155 and the other where we have 165. Now what would happen is that we now have to calculate how many men between these two horizontal lines. So it means that here we have 9. At this point we have 9. But at the upper point we have 70. Now the first 9 would not be in that range from 155 to 160. So we know that this 9 would have to subtract from the overall total of 70 men. So if you have 70 men altogether up to this point, the first 9 would not fall between 155 and 165. So how many men in total then? We would have to subtract 9 from 70, and that would give us 9 from 70 would give us how much?
61, sir.
All right, so we'd have approximately say 61 there. All right, for the other part of the question, it's how many men has height greater than 162 centimeter? So we would have done that first one, we would have done this as the second one. Now the third one, now we'd have to have height greater than 162. So what we want is all the height greater than 162. So all of these values that going from 162 would go this direction. So what it means that wherever these values greater than 162 correspond to the ogive, we would have to take those values at that section of the ogive. So when you go up and meet the ogive, we notice that the value of 162 would have approximately, say, 40 men with height 162, but we want men with height greater than 162. So if 40 men give you a height of, all right, so this is actually 42. So if 42 men would be a height of 162, and we want men greater than that, the number of men with height greater than 162, it means that we want height as 163, 164, and so on, going all the way up. So the first 42 men would have a height up to 162. So all we would have to do to get the number of men with height greater than 162 is that we subtract the first 42 men from the total of 100 men, and that would give us how much? 100 minus 42, guys.
58, sir.
Right. So that's how we would do our calculation. So based on the solutions, this is our calculation, right? So here we notice that for heights, for the height of men less than 157, we realize that 15 men have a height of 157, but for men less than 15, the first set of men less than 15 would be 14. So all of those would have, 14 men would have a height of less than 157 centimeters. Now for those values that fall between 155 and 165 centimeters. So all the heights that fall between 155 and 165 centimeters, what we would do based on the height of men that we get for 155, we would have 9 men have height of 155. And the upper value of 165, we would have 70 men have height of 165. But we know that the first 9 men would have a height less than the range of 155 to 165. So what we do, take away 9 from the 70 and we get 61. And just as we did with this last one here, we know that men with height greater than 162, it means that if the first set of men, which is 42 men, have a height of 162, that means all the men, all the rest of men, so the first 42 men have a height of 162, so the rest of men would have a height greater than 162. So to find out the rest of men, we take away 42 from 100, and that will left with 58 men. All right, is that clear, guys? Raise your hand if that is clear to you. All right. All right, next what we want to look at is the mode. And we're just going to start off with the mode, and wherever we stop, we will continue next class. All right, so the mode. Can anybody tell us how we would determine the mode of a set of values? We know how to find the mean. We know how to find the median. But what about the mode? How do we determine the mode for a set of values? Anybody, raise your hand. Go ahead, Miss Wesa.
A value appearing more than once. So like you'd have 1, 3, 5, 7, but you have the 3 like occurring more than once.
All right. So with that said, Miss Wesa, if we were to define what the mode is, then what would we say the mode is?
The number with the most frequency.
All right. So the number with the most frequency are the value that occurs the most.
Yes,
right?
sir.
So the value that occurs the most is the one we refer to as the mode. All right. So the mode of a set of values is the value which most frequently, or which occurs most frequently. All right. Now, so the mode is easy to determine. All we have to do is look at all the values, see which one of them occur the most, and pick that one out. Now, for this set of values, I think there is an error here in this question because the mode would not be 7 here. If we are working with the value that most frequently occurred, then the mode would have to be 4. So let me just make that correction here. So it says that the mode is 7, but for the set of value here, the one that occurs the most would be 4. So the mode is actually 4 for this first example. All right, is everybody in agreement? Now for the next set of value, you notice that each value occurred once. So there is no value which occurred more than the other. So in this case, we would have no mode. All right. You can lower your hand, Miss Wilson. Now, in this set of values, we would notice that 3 and 6 occurs pretty much the same, but they're the ones that occur the most. Because the 3 occurs 3 times, 6 occurs 3 times. So those 2 values occur the most. So in this case, if you have 2 values occurring the most, it means that we would have more than one mode. So the values that occur the most, in this case, we have 2 values occurring the most. So these 2 values, 3 and 6, would give us 2 modes. Is that clear, guys? All right, so in a situation where a set of values that has only one mode, we would describe the mode as being unimodal. A set of values which have 2 modes, we would describe the mode as being bimodal. And if we have a set of values having more than 2 modes, anybody can guess what we would call that?
Trinodal, sir.
Say that again, Miss Wilson.
Trimodal, sir.
I didn't quite hear what you said.
Trimodal.
Well, actually, I didn't say 3 modes, and I said more than 2 modes. So it could be 3, 4, 5, 6, and so on.
Sir,
So
multimodal.
all right, so maybe you could say multimodal. All right. But So here we would have more than 2 modes, so we'd say multimodal according to Mr. Lamar, because it means that we have more than 2, so we refer to it as multimodal. Is that clear, guys? Is that clear? Raise your hand if it is clear, guys. All right, good. All right, so moving on. Now, we may also want to find the mode of a frequency distribution. Now, if you notice what we just looked at would be the mode of a set of values. And for a set of values, we just pick out the value that occurs the most. Now, we can have one value occur the most, which is a unimodal. We can have 2 values that occur the most, which is a bimodal. And if we have more than 2 values, we call it a multimodal. Now, for frequency distribution, we have to go back to our histogram. All right. Now, a histogram is a diagram that is being constructed based on a group distribution table, right? And what we know, the histogram is a diagram which is used to represent a frequency distribution. Now, it consists of a set of rectangles. And these set of rectangles, remember we say that they can be not all of the same width. And in that case, when the rectangles don't have the same width, we would usually use the frequency, sorry, the area of the rectangle to represent the frequency. But if all of the rectangles or all of the bars have the same width, then the height of the bars would then be used to represent the frequency. All right. Now, in order to determine the mode of a frequency distribution, and remember, for frequency distribution, when we plot our histogram, if we're doing a group distribution table, what we would know is that the histogram for a group distribution may be drawn by using the midpoint of the class interval as the center of the rectangle. Now, just to remind you guys that our class interval is the same thing as our classes, all right? So we have first class, second class. And remember, each class has a lower and a upper limit. Now, if we are going to construct a histogram that the rectangles have the same width. Remember now, this is not the histogram where the rectangles all have different widths. This one, all the rectangles have the same width. So when we are using these rectangles of the same width, that means all the class interval would have the same class width. So in order to put these on, in order to draw our histogram, we find the midpoint of these rectangles and we put them at the center. All right, let me give you an idea. So here we have a diagram showing exactly what that means. Now remember that our classes going to have class width and they're going to have boundary values. Now in practice, when we're constructing histogram that have the same width, we generally put the base of the rectangles. The base would be the side that it sit down on, right? So in this case, the base would just be the bottom side that is resting on the line. So that's the base. So the base of each of these rectangles would start from one boundary value and ends at the next boundary value. So this diagram, this histogram would have represented the table that we were just looking at before, where the lower boundary value would be 149.5. The next boundary value would be 154.5. And so we would draw this rectangle so that one edge of this rectangle would be on the lower boundary value, which is 149.5. And the other edge of this rectangle would be on the next boundary value. Now, the height of the rectangle would be determined by the frequency of that class. So if that class have a frequency of, say, 8, and remember, we are using the same data. So remember that the first class has a frequency of 8. So it means that the height of this bar would be 8 on our frequency. All right. Anybody remember what the other value in that table was? So the first value was 8. The second value was what? 16. Anybody remember? All right, so the point is that in constructing our histogram for group distribution, where all the class widths are the same, we use the base of the rectangle from one boundary value to the next, and then the height give us our frequency. Now, so in terms of the table, just going back to the table, it was from the previous exercise, but just to show you that this is the table that we are using. It is the same table. This table is what are being used, right? So what we would do, we find the boundary values. And so the first boundary value, we remember our boundary values would have to be on our x-axis. So for the histogram, we are actually constructing based on our values of your x-axis and your y-axis. So remember now, your histogram has a value on the y-axis, which is the frequency values. The histogram have the boundary values on the x-axis. So if you draw your histogram, you would have to have a scale for your x-axis that you're going to put your boundary values. You have to have a scale on the y-axis that you're going to put your frequency. And so each of the rectangles start from the edge of one boundary value to the edge of the next boundary value. So you draw your first rectangle based on that, going up to the height of the first frequency for that class. And if you're looking at that class, the frequency would have been 8. The next class that would have started, we start with the next boundary value from 154.5. Then we would go to 159.5. So you notice that the base of this rectangle would start at 154.5 and it ends at 1. The next boundary value, which would end at 159.5. Now the height of this bar going to go up to 16 because the next frequency would be 16. So you draw your rectangle so that it goes up to a height of 16. And you come across, so that would be your next rectangle. And so our next rectangle after this would go up to a height somewhere, well, I'm not quite, based on the table, I'm not quite remembering the next value, but it's somewhere a little bit above 40, could be about 42. So we would do the same from this base. We would have the boundary value 169.5, and we go to the next boundary value, right, which is, I think it was about 164.5. And then we draw our height up to the frequency value for that class, which is about 42. And so we just construct our rectangle. All right. And so we keep doing that until we have constructed all the rectangle. And this now would have given us our histogram for that distribution where you have all the classes having the same width. Is that clear, guys? Is that clear to everyone? Raise your hand. Okay. All right. Now, so the first step in finding the mode of a group distribution is first to construct a histogram where all the widths, all the bars are the same width, and their base extend from one boundary value to the next, and their height would be the frequency of that class. All right, so if everybody is clear on that, so that's the first step. Now, in order to find our mode of the group distribution, we would have to use the histogram. So just like the median, in order to find the median for group distribution, we have to construct the graph with the ogive. In order to find the mode of a group distribution, we have to construct the histogram in order to determine the mode, right? So I hope you're understanding that clearly. All right, now how do we determine the mode? Now, for the histogram, you have to note that the extreme of the base of each rectangle represents the lower and upper class boundary. Now, what we can do when we have our histogram is to draw what we call a frequency polygon. So let us look what a frequency polygon is. So the frequency polygon is a second way of representing a frequency distribution. Now, it is drawn by connecting the midpoints of the top of the rectangle in a histogram by a straight line as shown in the following example. So, all right, so if you have a histogram like this and you're drawing a frequency polygon, what we are to do, we are to find the midpoint of the top of each rectangle. So the top of this rectangle, we look for the midpoint of the top of that. The next rectangle, we look for the midpoint of the top of that. Midpoint of the top of the next rectangle. Midpoint of the top of the other rectangle. Midpoint of the top of the next rectangle. And out here, we can imagine that the midpoint will be right there at the base. The midpoint will be right here somewhere there. And all we have to do is just draw a straight line to connect these dots or these midpoints. And that would give us our frequency polygon. So this is what it would look like. All right, those are the midpoints at the rectangle. So you would just connect those dots, and that shape would give you a polygon. which is referred to as a frequency polygon. All right, so we can, after we draw the frequency polygon, we can remove the bars of the histogram, and then you would have the polygon remaining like that. All right, so that's a frequency polygon. So that's how you draw a frequency polygon. For this one, we could use this information to draw a frequency polygon looking like that. All right. Now, the mode of the frequency distribution now. To find the mode of a frequency distribution, we draw a histogram and hence a frequency curve or a frequency polygon. The mode of the values of the variable corresponding to the maximum point on the curve. So the mode of the value corresponding to the variable. So this is what we really, this is what we use to determine the mode. So the mode of the value of the variable corresponds to the maximum point on the curve. So when we say the maximum point, we are referring to the highest point on the curve. So if you draw a frequency polygon, the highest point on the frequency polygon will give you your mode. Now, a second way that you can determine the mode is that the mode can also be obtained directly from the histogram. So you can use two ways to determine the mode. You can use the frequency polygon curve, or you can use the histogram bars, all right? And if we're using the frequency polygon curve, then we will draw the frequency polygon, and at the highest part of the polygon, the peak, you see where the dotted line reach here at the peak of the polygon, then you would come down. Remember, the mode would have to be read from the x-axis. So you go to the highest peak on the curve, and then you come down where it cuts the x-axis, you read the value off there to get your mode. So the mode is a value on the x-axis, all right? Now, one of the things that you would have noticed, so this is when we are using the frequency polygon. Now, this is another way that you could find the mode if you are just using the histogram. So you look for the highest bar, and you notice what they did here, from corner to the next bar. So the next bar to the left, the next highest bar to the left, and the next highest bar to the right of the highest bar. You take from that corner, you draw a line to meet the corner of the top here. You take from this corner, you draw another line to meet the top here. So you draw that X, then you use your ruler to draw a vertical line from all the way down, and whereby it cuts the x-axis down here, that's what your mode value should be. All right? Raise your hand if that is clear to you guys. So you would have seen two ways that you can determine the mode of a frequency distribution. You use the histogram or the frequency polygon. All right. Now, this is a table that you would be able to construct a histogram from this table. Now, this is not a group distribution table, but you can also construct a histogram. Now, in this case, you're going to use bars with the same width, and the midpoint of the bars, the midpoint of